factor special products. The list of special products, what we call the special products are product of a sum. If you have a plus b squared, it expands to a squared plus 2ab plus b squared. Product of a difference, if you have a minus b squared, becomes this. So when we talk about, so expanding is going from the left side of the equation to the right side. Factoring would be going from the right-hand side to the left-hand side. Factoring means you're going to write what you have as a product. So you have the product on this side, you have the expanded version on the other side, right? Product of a sum and a difference is going to give you the difference of two squares. So this is like a very popular one. A squared minus b squared, it's actually factored into a plus b times a minus b. So it's like, where are these a and b's coming from if we're using x and y's, right? It doesn't matter, this is just a representation, right? So if you have x squared minus y squared, you know that it can be factored into x plus y times x minus y, right? You have to be able to adapt and change the values for a and b. Factor the sum of cubes. So if you have the product of this guy here on the right-hand side is going to give you a cubed plus b cubed. And then the product of this this guy here will become a cubed minus b cubed. And then here I put a note that says, try expanding the product x plus a times x plus b and see what happens, because this is also a very common trick that is going to be used in factorization. Oh, that's an ugly 2. Okay, x plus 2 times x plus 3. I want to just do this one so that you see what happens. Yeah, when we expand it, remember, this is a very important property of products, which is you have to have x times this x and then x times this 3, right? So you have x times x is x squared. X times 3 is 3x. And then you have this guy here doing this, right? So you have 2 times x is going to be 2x. And 2 times 3 is going to be 6. So what's going to happen now is you are going to have x squared plus, I'm going to put 3 plus 2 together, times x plus 6. This is what happens. So when I expand a product like this, what you're going to notice is these numbers here, they multiply and become this guy here. And then the term that multiplies x is actually their sum. Like, why is this special? Because this is useful when we are going the other way around. If I have a problem, say factor x squared plus 9x plus 20. You can go, hey, do we have two numbers that multiply to 20 but add up to 9? We do, like 4 and 5. So I know already that this is going to be x plus 4 times x plus 5. Like this. This is like a thing that we are going to use a lot. So oh, you can ask, like, what if these numbers are huge, right? Like, it's never huge. It's usually like products that we know, like we've memorized.